Alright, let's go through the Chapter 7 sample test. Okay, this is sine inverse of -1/2, and it says find an exact value in radians, and it's a capital S, so we want the one where you take the sine out of. Capital sine, you take it out of the first and fourth quadrant, and the sine is -1/2, so it's down, so that's going to be in the fourth quadrant, and when it's only a half down, that is -pi/6. Cotangent is the square root of 3. So cotangent is cosine over sine, and this is a capital. Cotangent, we take it out of the same as the cosine, which is 1 and 2, and it's negative, so we take it out of 2, and the cosine would be negative there, and the sine is positive, so we want negative square root of 3, and the 1 down here, and that would be over 2 to be the special angles. So the angle would have to be where the cosine is negative and long, the sine is short, so that's 1, 2, 3, 4, 5 pi/6. Okay, cosecant. Cosecant, capital. Cosecant comes, that's a reciprocal of the sine, so it has to come out of the first and fourth, and it's 1/2, it's reciprocal, it's positive, so we're going to take it out of the first. And reciprocal of the sine, so this would be, the sine would have to be 2, and that is not possible for the sine of some angle to be 2, so no answers on this one. Cosecant is not equal to 1/2. It's either bigger than 1 or less than -1. Okay, 2. It says determine the exact values, if possible, in radians for these. Well, the cosine inverse is going to be an angle in the first or second quadrant, and the cosine of it is going to be take you right back to the point 9, and so there's the answer. Anytime the inverse is inside the regular, they will just cancel. It's when the inverse is on the outside, like now part B here, that you have to be careful. The sine inverse is going to pick it, capital sine is going to pick it out of the first and fourth. And the sine, well, this -9 pi/8, -8/8, -9/8, this is an eighth. This angle in here is pi/8 past. And the sine won't pick it from there. The sine is positive, so it'll pick it from the first quadrant where it's positive, and that would be 1/8 up, so this is going to be pi/8. Okay, now the inverse is on the inside, but now we got to do the cotangent, so now we got to do some more thinking, which is a challenge here. So sine inverse, that's in the first and fourth, negative square root of 3 over 2, so the sine is going to be way down there. Negative square root of 3 over 2, so the cosine has to be 1/2, because this has to be in the fourth quadrant. And the cotangent is going to be the cosine over the sine. So this the 2's are going to cancel, and it's going to be -1 over the square root of 3, or if you will, minus square root of 3 over 3 if you multiply numerator and denominator by the square root of 3. And now we got to do tangent inverse. That's coming out same as the sine, first and fourth, and it's positive, so it must be in the first. And the tangent's 3/4, so it's not all the way up to 1, which would be up there. 3/4 somewhere here, where the sine over cosine, that's 3/4, but this is 3/4 and this is 1. But we need to get the sine, which is this length. So we need to shrink this triangle and from 3/4 and 1 down to the radius being 1. So let's figure out how long the radius is right there, how long that is if it's 3/4 and 1. So 3/4 squared plus 1 squared is going to be 9/16 plus 16/16, which is 25/16 square root. So this long one is the square root of 25/16, or 5/4. And we got to shrink it to 1, so we're going to divide by 5/4 or multiply by 4/5. So to get this back to here, we're going to have to take 3/4 and divide it by, to shrink it, by 5/4, because that's how long it is clear to the outside, if that's 1 and 3/4, which means multiply 3/4 times 4/5, which means it's 3/5 is the sine. Okay. Now we have to do it with the similar stuff, but for u. And so the tangent inverse would come out of one of these two quadrants, and it's for u. Let's just make it be over here. So that means the length out here is u. And this side is 1. So we'll figure out how long the hypotenuse is. Then that'll be u squared plus 1 squared, square root, so it's u squared plus 1. And that's too long, and we got to shrink it, both the u side and this side. So we're going to divide all three sides by the square root of u squared plus 1. And that would shrink it down to here. So this side would become 1 divided by the square root of u squared plus 1. The sine would have been this u divided by the square root of u squared plus 1, and this would divide down to be 1. So that would be the shorter one in here. We wanted the cosine, so we want 1 over the square root of u squared plus 1. Determine the exact value of the tangent of 15. So there's now several ways to do that from what we have learned. The half angle formula would basically double the angle, so we could change this to the tangent of 30 by doing the tangent of negative 30 divided by 2. By the way, the tangent is odd, so you can move the minus outside. And the half angle formula for tangent, let's see, there's several there. Remembering, so it's sine, cosine, sine, so it's minus over plus, so it would be sine over 1 plus cosine of 30. I think that's what it is, but I can also use the tangent formula. I can say minus 15 is, say 45 minus 60, and use the difference formula. And so this would be the tangent 45, and the sine uses the same, tangent 60 over 1 plus tangent 45 times tangent 60, and tangent of 60 is square root of 3 over, is just square root of 3. Tangent of 45 is 1, so we got 1 minus the square root of 3 over 1 plus this 1 times the square root of 3. And if I were to multiply by the conjugate, well, I'll leave it like this. So let's see. I'm trying to remember which one of this is. So okay, this one comes out to be sine of 30 is 1/2 over, and we got to put a minus in front of this, 1 plus the square root of 3 over 2. And if I multiply, why don't I get this? 1 minus square root of 3. 1 plus the square root of 3. If I multiply numerator, oh, okay. Yeah. So now if I multiply this to rationalize, multiply the numerator and the denominator by 1 minus the square root of 3. Let's see what happens here. This will be 1 minus 2 square roots of 3 plus 3 over 1 minus the square root of 3 plus the square root of 3 minus 3. So that's a negative 2. So I have 4 minus 2 square roots of 3 over minus 2, which is minus 2 plus the square root of 3. And hopefully that's what I got here from the other one. Let me pull out another piece of paper so I can do this. Since I'm doing it two different ways, I have 1/2 over 1 plus the square root of 3 over 2. If I multiply numerator by 2 and the denominator by 2, I get, oh, and there's a minus on this. I get minus 1 over 2 plus the square root of 3. And if I rationalize this by multiplying by 2 minus the square root of 3, 2 minus the square root of 3, that times a minus 1 would be minus 2 plus the square root of 3. This would be 4. Minus 2 square roots of 3 plus 2 square roots of 3 cancel. And then minus 3, which is 1. So I get minus 2 plus the square root of 3, which is what I had doing it the other way. So you could do it either way. Sorry I mixed those two methods, but yeah. This one, use appropriate sum or difference to formula to simplify this. So sine of 122, oh, I could have also done this with just gone to sine of over cosine of these two. So there's lots of different ways to do this one. Sine of 122 cosine. Sine cosine minus cosine of the 122. Sine, that's the sine of an angle minus an angle formula. So it becomes, because sine of the first, cosine of the second, then sine of the cosine of the first, sine of the second, and so I got those switched, but it's still those first angle 122. So it's going to be the sine of 122 degrees minus 31 degrees, which is the sine of 91 degrees. Okay, and that would have been exact. Now I can't figure out the sine of 91 exactly, so that's where I would want you to leave that one. Page 2. Okay, so we're supposed to make this mess look like sine squared. We have secant squared minus tangent squared. That sounds like the Pythagorean theorem where we have sine squared x plus cosine squared x equal to 1. But secant would be 1 over cosine. So divide everything by cosine squared x, cosine squared x, cosine squared x. And I get secant squared x equals 1 plus tangent squared x. So secant would be secant squared is tangent squared x plus 1. Then we have minus tangent squared x minus cosine squared x. Leave the other side alone. So we get tangent squared minus tangent squared. And we have 1 minus cosine squared x. And we should recognize that as sine squared x. And we're to what we need it to be. 7. Cosine of 2 theta. Well, cosine of 2 theta, as you saw today, is several things. One of them is cosine squared theta minus sine squared theta. And if we factor out a cosine out of the denominator, we get cosine squared theta times cosine theta times cosine theta minus sine theta. And looking at this, this looks like one of the factors of the numerator. The numerator would factor to cosine theta plus sine theta times cosine theta minus sine theta. So these would cancel. So then I'd have to put the cosine into this. So this would be cosine theta over cosine theta plus sine of theta over cosine theta, which is 1 plus tangent theta. Now this one, cosine of alpha plus beta, so that would be cosine alpha, cosine beta, plus it would, on cosine goes to opposite, which would be minus, sine alpha sine beta, all divided by this cosine alpha sine beta, which I can put under each of these, cosine alpha sine beta, cosine alpha sine beta. In the first one, the cosine alphas cancel and I get cotangent beta. In the second one, the sine betas cancel and I get tangent alpha. Done. Now we have sine of theta divided by 2, and that is squared, so I have 2. And the sine of theta divided by 2 is plus or minus the square root of 1 minus cosine theta all over 2, and that's supposed to be squared. Well, plus or minus, but it doesn't matter when you square it, so we get 2 times, and the square will get rid of the square root, and we'll have 1 minus cosine theta divided by 2. The 2's cancel, and we have 1 minus cosine theta. Page 3. The sine is 4/5, and we're between pi over 2 and pi. That's in the second quadrant. And so theta is over here where sine is 4/5, so it's really long. And so, and that hypotenuse is 1, so if you go 16/25 from 1, you get 9/25, so the sine is -3/5. The cosine is -3/5. Doing sine squared plus cosine squared equals 1, subtracting the 16/25 from 1, and taking the square root, and then knowing that in that quadrant the cosine is negative. If the sine is -3/5 and we're in either 1 or 4, well, the sine is negative in 4, and so the cosine will be positive. So if we do 5/13 squared is 25 over 169 plus cosine squared of beta equals 1. 25 from 169 is 144. If I take the square root, I get 12/13 plus or minus, but since we're going to be in the fourth quadrant here, the cosine is positive, so it's going to be 12/13. Now if you don't get this right, you're going to have a hard time getting any points on 11, 12, and 13. Sine of 2 theta is 2 sine theta cosine theta by the double angle formula. So we got 2 times the sine of theta, which was 4/5, times the cosine theta, which is -3/5. So we got 2 times -12, which is -24 over 25. Cosine of beta over 2, according to the half angle formula, is plus or minus the square root of 1 plus cosine of double that angle over 2. Well, cosine beta is 12/13, so we got 1 plus 12/13, 13/13 plus 12/13, over 2. And let's right now decide whether this is plus or minus. So beta was in the first or fourth, and we decided it had to be cosine's positive and the sine is negative, so it's in the fourth. And if we take half of that angle, it's still in the fourth, and so the cosine is still positive, so we want the positive answer. And this is going to be 25 over 13 cut in half, so this is going to be the square root of 25 over 26, and we want the positive, and we know the square root of 25, so this is 5 over the square root of 26. Good enough. Cosecant. Well, we didn't do a difference formula for that, but we know the cosecant is 1 over the sine. And the sine of theta minus beta will be 1 over the sine of the first, cosine of the second, and if it's minus and the sine is the same sign, so that's minus cosine of the first, sine of the second. So we get 1 over sine of theta, 4/5, times cosine beta, 12/13, minus cosine theta, which is minus 3/5, sine of beta, which is negative 5/13. And so we got negative, 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 which is negative. So we got 48 minus 15, which is 43, 33 over 5 times 13, or 33 over 65, and that's under 1, so this becomes 65 over 33. Find all solutions to the sine of x equals 0.8. So let's do this. We can do it in radians or degrees. I'll accept either. Turn on the calculator, clear, and so I'm going to take the sine inverse of both sides, and so x is going to be equal to what the calculator gives me. If I do it in degrees, see my mode is in radians, so I'll change it to degrees. I'm going to do the sine inverse of 0.8, and I get 53.1 degrees approximately. And the sine I would do plus k2 pi, so it's all solutions. That's half of them. The other half, when you're doing sine, is 180 minus the angle the calculator gave you, 53.1, plus k2 pi, and 180 minus that answer we had, oops, and that's 54.86. That can't be right. Oh, I did 108. Okay. 180 minus that answer is 126.9. 126.9. Oh, and I should be doing, if I'm doing this in degrees, this would be 360, K360. So our two answers are, we have x such that x is equal to 53.1 or 126.9 plus K360. I'll let you, that's where K is an integer. Okay. Both of these are plus K360. Maybe I had to put it both of them like that so that you don't make a mistake on that. Okay, where the secant of x is 7. Secant is 1 over cosine, so the cosine of x must be 1/7. So we do cosine inverse of 1 divided by 7, and it says 81.7.8. 81.8 degrees approximately. And to get both angles for the cosine, we do plus or minus, plus K360, where K is an integer. Alright, now we got to do more solving. Cotangent is -1. Well, if cotangent's -1, then the tangent of 2x is the reciprocal of that, which is also -1. And so we'll do, to get the tangent off of this, we'll do tangent inverse and tangent inverse. Where's the tangent -1? We take the tangent out of the first and fourth, so that would be minus pi over 4, or minus 45 degrees, plus K 180, or pi. And that's what 2x is. So then you have to divide by 2, and so we get x is, oh, and I said between 0 and pi over 2. So we should be doing this in radians. So 2x equals minus pi over 4 plus k pi. And that's both answers because we're doing pi. We divide by 2 and we get x is negative pi over 8 plus k pi over 2. So negative 1/8 pi is not between 0 and 2 pi, so we're not going to do negative 1/8. But if we add 4/8 to that, we get 3 pi over 8. If we add 4/8, pi over 2 is 4/8 pi, to this we get 7 pi over 8. If we add 4/8 to that, we get 11 pi over 8. And if we add 4/8 to that, we get 15 pi over 8. If we add that, we'll be past 16/8, which is 2 pi, which would be too big. So we stop there. And finally, the last one. So we got sines and cosines mixed up here, so it's hard to change just a plain cosine, but it's easier to change the sine squared. So we're going to replace the sine squared with 1 minus cosine squared x. And so I can distribute the 4 and I get 4 minus 4 cosine squared x equals 1 plus 4 cosine x. Let's see, let's get we've got a quadratic happening here, so let's get it all equal to 0, and let's make the squared one be positive. So I'm going to subtract 4 and add 4 cosine squared x to both sides, so it'll be 0 over here. This minus 4 cosine squared will become 4 cosine squared x when we add it to both sides, positive 4 cosine squared x. Then we're going to have plus 4 cosine x, and when we subtract 4 from both sides, we're going to have minus, this is not what I wanted, we're going to have minus 3. And does that factor? 4 and 1. I don't think it does. So, not what I wanted, but I can use the quadratic formula and put in a is 4, b is 4, and c is negative 3. Oh, it does factor. Okay, so it says make it 2 cosine x and 2 cosine x. And if we, oh yes, if we do 3 times 2, that'd be 6. And 1 times 2, that'd be 2. So if I do plus 6 minus 2, that'd be plus 4. So there it does factor. And so from this I get, setting that equal to 0, I get 2 cosine x minus 1 equals 0, add 1, divide by 2, cosine x equals 1/2. Over here, setting that equal to 0, subtract 3, divide by 2, and I get cosine x equals negative 3/2. Cosine is never below minus 1, so there's no solutions out of this part. So we got to go for the cosine is 1/2, and that is at pi over 3 plus k2 pi. But if we're going to do it between 0 and pi, pi over 3 is one answer. If we add 2 pi, it's beyond 2 pi, so that is the only answer for this.